Hi everyone, I'm Danny from Huawei Mass Data Storage, and today I will introduce a tool designed for improving performance of OceanStor Pacific Series in HPC scenarios, DPC. DPC, short for Distributed Parallel Client, runs on a compute node to function as a storage client. Clients that use the standard file access protocols can connect to only one storage node and provide only the POSIX interface for data access, which is insufficient in many HPC scenarios. For example, in weather forecasting, the MPI-I/O framework is required for concurrent data access. In satellite mapping, the single stream bandwidth for receiving satellite data must be greater than 2 GB per second. In supercomputing centers, the performance of a single fat client must be greater than 5 GB per second. That's where Huawei DPC comes in. DPC can connect to multiple storage nodes concurrently and provide the standard POSIX and MPI-I/O interfaces for upper layer applications to achieve better compatibility and higher performance. Now, let's learn about the main advantages of DPC over NFS. In a typical HPC I/O model where multiple processes read and write one file, threads must cooperate with each other to avoid read and write conflicts. MPI is a standardized method for exchanging messages in this context. NFS does not support MPI, whereas DPC supports the MPI-I/O interface, which can significantly improve I/O performance. Also, one NFS client can connect to only one storage node, meaning client performance is subject to storage node configurations. However, DPC can connect to multiple storage nodes through RDMA, eliminating storage bottlenecks and improving the single client and single stream performance. When data is written over NFS, 2 write I/Os are required. It must be written to a storage node first, and then the node disperses the data to other storage nodes. DPC disperses data first and directly writes it to different storage nodes, meaning only one write I/O is required and reducing the read and write latency. NFS-based load balancing occurs when storage nodes are mounted to NFS clients, but a frequent problem is service burst, which may cause bottlenecks on a single storage node and impair performance of the entire system. However, DPC can connect to multiple storage nodes to implement I/O level load balancing among the storage nodes. DPC for OceanStor Pacific Series is the secret to adapting to and accelerating performance in diverse HPC scenarios. That's all from me today. Thank you and see you next time.